Hello students, welcome to this lecture in which we're going to talk about linear cipher. What is a linear cipher? Sometimes it's also called affine cipher. And basically it's a combination of decimation cipher and scissor cipher. So we use addition and multiplication together. That's what we're going to do. And the key for the linear cipher consists of two things. Has two values, K and delta, where K is multiplication key, and delta is addition key. So to encrypt the letter, the letter in position I, we will use the following formula. We will use the following formula. Y is equal to K times I plus addition key modulo 26, mod 26. So the formula just combines multiplication and addition together. So let's look at the example of the encoding. Let K equals to 5. Remember, not all of the keys work, right? Only some numbers work. The units, right? The units. So K is equal to 5 and delta is equal to 7. So we have two keys, and the assignment says encode math using these two keys. And like always, we need an alphabet, so we build it up. So we build the alphabet. We number the letters. So we would know the numeric position. And remember, we start from 0 and we have to end at 25, right? So we started from 0 and we went all the way to 25. So let's start encoding. So we use letter M. M position is 12, so we use 12. And we calculate 12 times 5, that's our K, plus delta, and our delta is 7. And we do mod 26. So let's calculate it. 12 times 5 is what? 60. So it's 67 equals to 67 mod 26. And 26 goes into 67 twice. So it's 67 minus 2 times 26, or 67 minus 52. And that's going to be 15. So this equal to 15. and 15 is P. 15 is letter P in the alphabet. So the next letter that we need to encode is A. And if you remember, if we just use multiplication cipher, A doesn't go anywhere because it starts with 0. So we have 0 times 5 plus 7 modulo 26. So it's 0 plus 7, so it's 7 modulo 26. And it's just 7 because 7 is smaller than 26. And 7 is H. Then the next thing we do is letter T in word math. T is 19. So we have 19 times 5 plus 7 mod 26. So if we multiply 20 by 7, that would be 100. And so it's 95 plus 7. 95 plus 7 is 102. So we get 102 mod 26. So maybe we should use a calculator. So we take 102, we divide by 26, we get 3 times. So it's 102 minus 3 times 26, so we get 24. So we get 24, which is Y. And the last letter is H. H is 7. So it's 7 times 5 plus 7 mod 26. So that's 35, 42, right? 42 mod 26. So we can subtract 42 minus 1 times 26. So we're going to get 16. And 16 is Q. 16 is Q. So that means the word math encoded with affine cipher will be, math will be encoded with H, Y, Q at the end, and the first letter is P. That's encoding. Unfortunately, decryption is not that easy, so let's look at the decryption. So decryption is going backwards. So since we're doing 2 steps, we have to undo 2 things, and since addition is the last thing that we do when we encrypt, it's going to be the first to be undone. So undo addition first. Undo addition first. And since we always move forward and we have encryption key delta, and we know that upside down delta plus regular delta should be equal to 26, which means the upside down delta, which is officially called nabla, is 26 minus delta. 26 minus delta. And second thing we're going to do is we're going to undo multiplication. We're going to undo multiplication. To undo multiplication, we have to look up in the table. So given encryption key K, we need to look up decryption key J in the table. And our table is given. Don't memorize the table. We're going to look it up. We're going to look it up here. All right. So let's try to do it in our example. So let's do an example. Decrypt PHYQ, decrypt PHYQ, which was encrypted by using k equals to 5 and delta equal to 7. All right, so we have a delta, and so we have a delta. Delta is equal to 7, means that nabla is 26 minus 7, which is 19, and k equals 5, that means j is equal to, so for 5 we have 21. For 5 we have 21. So let's try to decode. P is, so we need the alphabet probably. Let me get some space here and get the alphabet out. So here's our alphabet. We will copy it from here, and we're going to paste it over here. And now we're going with letter P. Letter P is 15. Letter P is 15. So again, we undo addition first. So it's 15 plus 19 times 21 mod 26. So let's try to evaluate this. Probably calculator is the best thing to use. So 15 plus 19, we calculate this first, we multiply by 21, we're going to get 714 mod 26, if I did everything right. So we divide by 26, so it's 27 times. 27 times. Then we do the subtraction, 714 minus 26 times 27. So we're going to get letter number 12. And letter number 12 in the alphabet is M. So the next letter that we need to undo is H. So H is 7, which means 7 plus 19 times 21 mod 26. So we need to calculate this quantity, which is 7 plus 19 times 21, 546. 546 mod 26. Mod 26. So let's do this. We take 546, we divide by 26, so it's 21. So it's 546 minus 21 times 26. So we get 0, and so 0 is 8. The next letter that we're going to need is Y. So letter Y is 24. So we get 24 plus 19 times 21 mod 26. 24 plus 19 times 21. 903. So we get 903 mod 26. So take and divide. So it's going to be 34 times. 34 times. So we take 903, we subtract 26 times 34. So we get 19, and 19 is T. Oh, so far we're doing well. The last letter was Q, if I remember correctly. Let's look. Q. So Q is 16. 16 plus 19 times 21 mod 26 mod 26. Let's do this out. 16 plus 19 times 21, 735 mod 26. We divide by 26, we get 28. 28. Let's do the last step. 735 minus 26 times 28. We got number 7. What is 7? 7 is H. We did everything right. We got our math back. MATH for P, H, Y, and Q. And that's a linear cipher, which is a combination of multiplication and addition. There is one more cipher left, and this will be the end of the semester in the next lecture. And I'll see you then.